No, so, all right. So the practice should be 1.4.1 set 1, yes? So what we're going to do is we'll go through these here. Now, there's 15 of them for today. And most days, we're not going to do every single one because, again, for most of this here, I feel like y'all are comfortable with these here. At least you should be comfortable with these types of problems, yes? So let's do, what do y'all say, 6? We'll do 6 of them. Now, looking, because I think they're in groups of 3, aren't they? So out of the first 3, let's pick one. Number 2, there's one that looks challenging out of those first 3. I mean, especially when we look at the answers where F, G, H, J, and K are all fractions, yes? It looks like it could be a little daunting. Now, again, one of the things I will say with any of the ACT, especially the math, is always keep an eye on the answers, the answer choices that you have, especially when you're solving. Because we can start removing answers that don't work, or start seeing and kind of getting towards answers that do. So when we look at this here, well, the first thing we'll need to do is what? We need to distribute the 5, yes? 5 times x is equals, what do we need to do next? We need to add 30. So, okay, before we go on to the next step, we'd have 5x equals what? 22, yes? Now, at this point here, is there any way for this to be negative? No. The only way it'd be negative is if we had to divide by a negative, yes? So, gone, gone, gone. Now we got a 50-50 shot. Because anytime we can remove answer choices, we're increasing the likelihood that we can guess it right. So even if we get to a point where, okay, I don't have anything left, I don't know what to do next, we at least give ourselves a better shot at guessing it. But the next thing we are going to do is what? Divide by and get, which is k. And that's it. That's all I have to do for this here. Any other questions on this one here? Do we want to look at number 30? Okay, what would we do first? We distribute, so we do 3 times x, which is 3 times negative 7. We can add 21 to both sides. Which tells us that 3x equals, we have to divide by 3, which would be, and a lot of times, as long as we know kind of the steps that we're doing or what we should be getting or the kind of answers we get, we can start taking out the ones that don't make sense. Okay. So there's different things we can do for this here. I mean, one, we can go about solving it, yes? 2 times x is minus 6. Then negative 4x, because it would be minus 6, because 2 times negative 3 would be negative 6. Negative 4 times x is negative 4x. Negative 4 times negative 6 is going to be plus equals 7x. Now we can combine like terms. 2x minus 4x is negative 6 plus 24 plus 18 equals 7x. We can add 2x. I would add 2x mainly because we have the x and 18 on one side. What do we have on the other? Just x, yes? So let's just get all the x's together. We could have subtracted 18 from both sides. Then we need to subtract 7x. So we'd end up moving everything back the other way. Divide by 9. X is equal to I'm going to do this a little different. Let's say we subtract 7x from both sides. I'm not going to combine anything. I'm just going to say 2 times x minus 3 minus 4 times x minus 6 minus 7x. What will this equal? 0, yes? Now, so this here is the graphing calculator, yes? Now, for most all of you, you haven't had Algebra 2 yet. So today, incidentally, was the first day we messed with the graphing calculators, yes? Now, again, these are called graphing calculators. So guess what they can do? They can graph, yes? So I can pull up y equals and say 2 parentheses x minus 3 close parentheses minus 4 parentheses x minus 6 close parentheses minus 7x, yes? Which seemed like a funky thing to do, yes? Now what did we say this was equal to? 0. So if I graph it, I'm trying to see where the y value is. Well, where is it? 0 is when it crosses the x-axis, yes? Graph 2. Or we can say second graph, which will pull up a table. Oh, let's try one more time. Second graph, because I think that fly landed on it, messed it up. Well, when x is 2, y is? So the answer is? But again, this mainly works because I got the function equal to. Well, maybe that's a fluke. So if we look at this here, so we could go through solving it, yes? I could subtract the 2 over. Yep. Just going to make sure. Well, I don't like flies, especially with this board, because it actually pulled that up. Yeah. It's sensitive enough that a fly landing on it will actually recognize it as a touch. So we'll minus the 2 over, which will make this be 0. Yes? Now in the graphing calculator, 5x minus, so I could say y equals, clear that out, 5x minus, I think it was 4 parentheses, yeah, tell me the rest. What, one more time? Minus? Oh, just minus? Okay. Minus, parentheses, plus 4, minus 2. Yes? Graph. Okay. It did not give us a whole number, did it? No, because we can see it's crossing between what 2 spots on the x-axis? 1 and 2, yes? Are there any answer choices that are between 1 and 2 on the positive side? 1/2. Are there any others? Well, negative 1/2, but that'd be between -1 and -2, yes? Or actually 0 and 1. So between 1 and 2. So if we look at this here, so A, -1/2 doesn't work. Well, 1/2 is between 0 and, so that doesn't work. 1 doesn't work because it'd been a whole number. 3/2 works, but E is too big. B. I didn't even have to actually calculate what the exact answer is. This is the only one that works. That's it. Questions on this here? Yeah, I mean, if you could use it, use it. A lot of the stuff where we plug in fractions, it's easier for y'all to plug in a fraction on the yellow calculator, the ones that y'all have, because it's just one button. For the graphing calculator, you can still do it, but it's alpha y equals enter to get it. Alpha y equals enter. Takes 3 steps where the other one takes 1. These here, the 30xs, the ones that y'all have in front of you, will simplify radicals. So the square root of 125 is 5 square root of 5. If we type it into the graphing calculator, let's clear that. Second square root 125, hit enter. It gives us the decimal. It doesn't give us the actual number. We have to actually find it ourselves. Go on and type the square root of 125 in the calculator in front of you. What do you get? So if it wants it in simplest radical form, use those. If we want, both can do it. So those calculators have their advantages, and this one has its. So you can actually have both on the ACT. You can only have one on your desk at a time. That means you just put the other one underneath your chair. Yep, if you need it, you just switch it. Technically, I think by the rules of it, you would raise your hand. We would acknowledge you. You're just pretty much make the motion like switching calculators, and you switch. That's it. Because if we work this out, it would be 5x minus x minus 4 equals 2. We can add the 4 over, which would tell us that this is equal to 6, yes? What's 5x minus x? So then I can divide by. Bless you. I think y'all would have got it faster just graphing it at this point. Do you all want to grab one and try it yourselves? I want to grab one so at least you guys can get some practice with it. So, like we're graphing them. Yeah, so you already have one. Yeah, so I mean, we could actually get it equal to 0 and graph the thing, and it'll give us the answer. Yes. Yeah, and that one there is nicer than these, because you remember doing imaginary numbers last year, where we divided complex numbers, where we had to put it in parentheses, divide parentheses. That one you can type it in as an actual fraction, and you don't have to convert it back to a fraction. Yeah. Those are $20, $20 to $30 more expensive than the other ones that y'all have. But hopefully eventually we will start getting more of the other ones, because those, it takes 4 AAA batteries. Yep. The AAA batteries, we will replace all of those sometime throughout this year, which I've not price checked AAA batteries recently, but I have a feeling when we're going through 4 times 80 batteries a year, that's going to be more than $20. No, it never is. So we can look at this one here next. So if we want to do this by the calculator, we just need to subtract the 10 over. And we're subtracting because the 10 is positive. If the 10 was negative, we would not subtract, we would add. So really we're just saying that we have minus 10 is equal to 0. So over here, we're going to hit y equals first to graph. So you can hit clear if you want on that, and we can say 6x minus, all right, someone's going to have to help me out because that's all I remember. I think it's 5 parentheses. Okay, so minus parentheses 5x, then plus 7, close parentheses, minus 10. And then we hit graph. Okay, so it's way down there, yes? So most likely, we're looking at a bigger number. Now, on this graph, standard form is going to be negative 10 to 10 on the x-axis. The y-axis on standard is negative 10 to 10. Now, what we can do is say second graph. So we get a table, yes? So we're looking to where it's 0. Well, at 0, at negative 17, negative 16, we can see it's coming towards 0, yes? So we can scroll down. And at 17 it is. And that's our answer. You guys were looking for where this function is? 0, yes? So our answer, yeah, y1, what this equals to. Because essentially we're treating this like a function. Let me go back over here. What we're essentially treating this as is y is equal to 6x minus 5x plus 7 minus 10. This is what we're thinking of the function as a graph. And we want to see where it is 0, where it equals 0. So we can do this here. Questions on this here? All right, how do we feel about these here? This makes it feel better, especially seeing that we don't really have to do much. Let's look at one more. I'm going to show you one more neat feature. Let's go all the way, because make sure. Nope. 14, 15. Let's look at the last one. Now, the reason I do that is every single other one except for number 5, which you already did, gave us whole number answers, yes? This one does not. But we can still treat it the same. So we need to get everything on the same side, get this equal to 0. So what would we do? Subtract 1/6 from both sides, which now it's equal to 0. And on the ACT, especially if they give me a booklet, an actual paper form of it, I'll write over the top of it, like I just did here. I just put minus the 1/6. If it was negative 1/6, I'd write over the top of it, so a plus sign. Now we can type this in. Now the way we type this in, so again, we'll do y equals. We can clear this out. Alpha y equals enter. Alpha y equals enter. We have a fraction. So we can type the first one in. 2x over 3. And you have to make sure you do hit the right arrow so that you get out of the fraction. Plus, we'll do it again. Alpha y equals enter. X over 2 minus alpha y equals enter 1 over 6. and hit graph. Okay, we're looking for some number that's really close to 0, yes? So are there any answers? Oh, well, all of them look close to 0, yes? 1/30th, 1/15th, 1/7th, 1/5th, 1/3. Those are our 5 answer choices, yes? Now, our normal number system is not going to tell us what it is, okay? Now, again, we're looking for where the y value is what? What I can do also, if you look at the letters or kind of the stuff up in blue across the top, you see one of them says CALC, calculate. We can hit second trace. What's the first one? So if I hit enter on that, you see how it gives X and a little flashing bar? What it's saying is, give me a value for X, our X value. Well, let's pick it, because we have 5 choices, don't we? Which one looks like it might work? 1/30th, yes? 1 divided by 30? 1 divided by 30. We could do the alpha y equals enter, or we can just say 1 divided by 30. Hit enter. Do we get a y value of 0? No. Okay, so I can go second calc value. Give me another one. 1 divided by 15. Enter. Is that 0? No. Second calc. Enter. 1 divided by enter. Is that 0? So what's the answer? That's it. And these 84s aren't the strongest calculators out there. There's ones that are even better than these. There's some that you didn't even have to move anything over. You could have typed this equation as it's set from the beginning, said solve, typed it in comma, the variable, close parentheses, enter, and it would have told you the answer. No, that's banned on the ACT. SAT, I don't think so, it's not. But those are TI 89s or the